All right, this is means of samples, part 3. So we've talked about what the whole purpose of hypothesis testing is. We've talked about what the general idea of the means of samples process is being able to figure out, would I have been able to draw a group out of my bigger population that by chance had the same qualities as this group that I'm testing. Okay, this is the setup for what we're doing. So I'm going to walk you through this step by step using an actual example that I went and found this afternoon out of a research article, so we can be working with some real world stuff here. So and I'll post the link to this particular psych survey in case you're interested in looking at it. So I found an article that was done in 2020, and they used a self-report anxiety symptom scale. And they were trying to find out if there were differences in different majors in levels of anxiety, and then also if there were differences between men and women, males and females, within this study. So they used an anxiety rating scale where it's possible to come up with a result between 20 and 80. 20 to 44 is considered normal, 45 to 59 was considered mild and moderate, 60 to 74 was considered severe, and 75 or higher is considered extreme. And this was called the Zurich Self-Rating Anxiety Scale, and it's actually been around since the 70s. It's a really old one. So what they found in their results was that education majors had significantly higher levels of anxiety when compared to STEM majors, science, technology, engineering, math. So education majors were higher. They also found out that female students had higher levels of anxiety than males. So what I'm going to do is use this example of this particular, it's actually more of an example of how we would use this test or this inventory, this Zurich anxiety inventory, to demonstrate this idea of a hypothesis test with means of samples. And I have a piece of software I'm going to pull up in just a minute for video 4, I guess it will be. So again, so far we've been interested in comparing the scores of individuals. Now we're interested in comparing the scores of groups, right? So what they were comparing was the scores of the women who were education majors, or the students in general who were education majors, significantly different than the scores of other students. I'm simplifying it because comparing actual subgroups and populations is a bigger statistical thing that we'll get to later this semester. But for now, let's just say they were comparing them to the general student population. And also comparing the female students to the general student population. How do we do this? Using these test results that range anywhere from a 20 to an 80. Because let's assume, so we have this setup, all right? Let's assume that we decided, okay, we know that female education students have a high risk of anxiety. Let's find 100 female education students at Drury, and with 30 of them, let's give them some type of anxiety reduction intervention and see if we can make a difference, right? Let's do an anti-anxiety program that 30 of them can be involved in out of 100. And we're going to use this Zurich anxiety inventory that they used in this study to see if we've made a difference or not. At the end of our intervention are the 30 female education majors who did our intervention. Are they significantly lower than the bigger group of 100 female education students that we surveyed, right? This example is going to be our setup for the rest of the time that we talk about means of samples. The first key component of this is to realize if we draw sets of 30 students out of this 100, this is the number I was going to tell you earlier. I did the math on this. The number of possible combinations we would have is 29 with 23 zeros after it. I don't even know what number that is, right? That's basically an infinite number of combinations we could have. So what we want to know is, of those infinite combinations, how likely is it that a bunch of them would have a similar level of anxiety to the students that we did an intervention with anyway? Again, going back to the bigger question, is there any way that my result is purely by chance?